3.2. Is everybody with me? 3.2. Determine whether Rolle's theorem can be applied to f on the closed interval a comma b. Select all that apply. F of x equal to pi through, okay, only looking at all right. Normally, so I'm looking at the pi, go up and down.
I do too.
Okay, so, but I am only interested in where? Are you with me? That's the cosine that I'm only interested in is where my interval is. This is the only part I am interested in.
The intervals.
Where my interval is, which is pi to where? 3 pi.
Okay.
So it's very interesting. You have to pay attention to your interval, okay? Because other part, it's none of your concern. Because it's only asking you, hey, can I apply it here? Okay? So looking at this graph, everybody can tell this is what? Continuous function. And every part is what? Differentiable because there's no sharp points. So to f and f prime, we already met the first two conditions. What's third condition says? The end point has to be same, right? Which means f over pi has to be same as f over what? 3 pi, which is the same because they're all what? -1. This is 3 pi, -1. This is what? Pi -1. So all the condition met. So you're gonna say yes, right? So Rolle's theorem applied. Now let's find the critical point. Is everybody with me so far, so good? So if you want to know this, if it's like you cannot see yourself, graph it, okay? And then only look at your interval that you are interested in, like what I just did here. All right? Okay, now let's find it then. Can I just write it here?
Yeah.
This is a short one. So f prime of x is what? It's a cosine. What's the derivative of a cosine? Negative sine x. And I'm going to set them equal to what? 0. So when the sine is 0, let's graph it. Sine graph looks like what? Wait a minute. Oh, a minute. I grew up wrong. Everybody see that? I need to start at 0, but I started where? Pi. I made a mistake. Okay. So graph that I want is start at 0. So I go up and come down. Okay, this is my graph for the sine. So what I need is what? When sine is 0, which is where? Pi, and then what? 2 pi, and then what? 3 pi. All right? So if Rolle's theorem can be applied, find all values C in open interval. So if it's not, this become an open interval now. Are you with me, class? So what open interval means? So this is what? Open. And this is what? Open. So what is only your critical points then? 2 pi. So that's why your answer is only what? 2 pi.
Okay.
Okay, Quincy, what was your question?
No, I got it now.
You got it now? Okay. So did everybody see why pi and 3 pi is now your answer?
Yeah,
Because
it's
it's an
called
open interval. It doesn't, your differential, remember, It has to be different for where open interval. It has what continuous and where closed interval, which it matters. Since I don't want the n value, so that become only one critical point, critical number.